In this video, we're going to talk about combinations with replacement. So we'll do two problems, one where we solve for r and one where we solve for n. In this problem, we're going to solve for r. We'll do C9r equals 126. When we're ready, we'll hit the button. So this is a little algorithm you can use on any of these problems. And the first thing is we always start with n and multiply 1 down and then 1 down again. So 9 minus 1 is 8, and then we want to take the product of the range. So 9 times 8 is 72. We want to divide 72 by our combination answer. If it's not an integer, we move on. We know that that's not a possible answer. Now we'll go from 9 to 7. So 9 to 8, then 9 to 7. Take the product of that range, divide by our combination answer, we get 4. If it's an integer, the last step of the algorithm is, does this answer equal a factorial from 1 to n? So we first check 1 factorial, 2 factorial. It does not. And because 3 factorial would be 6, which is greater than this. So now we go 9 to 6. Take the product of the range, 30, 24, divide by 126, which is our combination answer. We get 24. Now we want to check, is 24 a factorial? It's not 1, it's not 2, it's not 3, but look at this, it is 4. If it's a factorial, this is an answer for r. So we found an answer for r. The beauty of this algorithm is it will check all possible answers. So let's go ahead and repeat that step. We're going to go from 9 to 5. Take the product of the range, divide the product of the range by the combination answer, which in this problem was 126. We get 120. Is 120 a factorial? We check 1, 2, 3, 4 factorial. It's not, but 5 factorial it is. And we found another answer for r. So if we keep looping through this problem and the process, we're going to find no more answers. And once we loop through 9 to 3, 9 to 2, 9 to 1, we're done with the algorithm, and then we scoop up all our answers that were factorials, and we get 4 and 5. So it's the same 3 or 4 steps over and over and over again. You start at your n, multiply by n minus 1, and then you take that, multiply by n minus 2, get the product, divide by the combination answer, check if that result is a factorial. If it is, that's an answer for r. If it's not, skip it and move on to the next step. So that is solving for r. What if we want to solve for n? So I'll take another example. I'll paste this in here. We want to see Cn3 equals 165. We want to solve for n. So we'll go ahead and, let's do this here. There we go. Okay. So this algorithm's different when we solve for n. The first thing we want to do is calculate r minus 1. In this problem, r is 3, so we want to take 3 minus 1 is 2. We take this relationship here. So we start at n and we multiply all the way n minus 1, n minus 2. We're going to have 2 terms, 2 more terms besides n. So if we count n as our first term, we want 2 more terms decreasing by 1. We divide that by r factorial, which in this case is 3, and we set this equal to 165, which is our combination answer, and I just do 1, so we have a nice clean proportion. We're going to simplify 3 factorial, which in this case is 6. We rewrite this simplified. Now we can cross multiply. We take this piece here times 1 here, and this piece here times our combination answer. When we do that, we get a simplified expression. Now what we want to do is we want to get all the factor pairs for 990. So we'll go ahead and list those out. Then we want to take them and arrange them in order. Because r was 3 up here, I'm going to go back to our original problem. R was 3. We want to see, are there any terms starting at n and going down by 1, so n, n minus 2, n minus 1, where we get 990. And if I go through this list, I want to find 3 consecutive integers. So 1, 2, and 3 are consecutive, but the problem is the product of that is 6. That's not an answer. If I scan through this entire list and look for 3 more consecutive integers, I only find one more group of 3, and that's 9, 10, 11. When I multiply those out, I do in fact get 990. So that is our answer, 9, 10, and 11. And so the key with these is R could be 3, R could be 4. You want 4 terms or R terms decreased by 1 such that the product is the cross multiplication of this step here. And that's how you back into the answer for n. So that's it. Thanks for watching.